Hello students, today we are going to be looking at experiment 6. This is the extraction of an acid, a base, and a neutral compound from a mixture. So in my test tube here, I have a mixture of 3 compounds, and I'm going to ask you to kind of zoom in on the test tube here. And I'm going to twist it around for you as we're looking. And so in this test tube, I have 3 different solids. And so if you'll see here, I have a white solid that's quite powdery. There's a solid that is also white that is somewhat crystalline, but much more noticeable is a very dark solid that I have here. And the 3 compounds listed here are the same 3 compounds that are listed in your protocol. So we have benzoic acid, 4-methoxyaniline, and naphthalene. So with these 3 solids, we're going to try to separate them using acid and base principles. So what I'm going to do here is start by dissolving my solid here in ethyl acetate. So I'm going to measure 3 milliliters of ethyl acetate and add it to my mixture. Okay, and the next thing I'm going to do is add a spin vane. A spin vane is a magnetic stirrer, so this one is in the shape of a triangle. We usually use these for round bottom flasks, and the triangular shape helps scrape anything from a round bottom flask. In this case, we just want to ensure that everything is mixed together thoroughly in the test tube. So I'm going to go ahead and place that here. Okay, I'm going to stopper my test tube, and then I'm going to go ahead and start the stir function. All right, and we're going to stir this solid so that it's very, very well mixed for about 5 minutes. We'll come back in just a little bit to see what our solution looks like. So it's been about 5 minutes that we've had our sample stirring here, and I'm going to go ahead and use a pipette to take I just want a few drops of this sample for the TLC that we will be doing later. This will be our standard, so because our mixture does contain the 3 compounds that we're trying to separate. So all I need is a few drops here. Okay, now the rest of our compound here is looking pretty good. It's nice and dissolved. It is a nice dark color. I'm going to go ahead and remove the spin vane. I'm going to use my stir bar retriever here. The next thing I'm going to do is add some sodium hydroxide. So I'm going to add 1 milliliter of 5% sodium hydroxide to my solution. And if you notice, we now have 2 layers inside of the solution. Okay, I'm going to stopper my test tube here and invert to mix the 2 layers. And I'm going to let the 2 layers settle. So if you notice, we have a nice dark upper layer and a pretty clear lower layer going on here. We would be able to determine by density of the solutions, of the solvents, which is the upper layer and which is the lower layer. You could probably also tell from our previous situation where, you know, all of the solids were dissolved in the dark liquid, and now we have this magical little smaller layer at the bottom. Okay, so my next job is to remove that lower layer, and I'm going to use my pipette again, and the goal is to remove only that lower layer. I'm going to repeat the addition of sodium hydroxide to my solution, and again we see the formation of 2 layers. I'm going to go ahead and stopper one more time and invert to mix our layers here. And again, I'll set it down to allow the 2 layers to settle. Again, I'm going to take my pipette and remove the lower layer. And I'm combining the 2 lower layers together. So it should look like this layer is all, you know, lower layer. So this is your aqueous based layer. And we see, you know, left behind in the original test tube, we still have dark solution. All right, students, in this segment, we're going to ensure that we can isolate the benzoic acid from the mixture. So I have here the aqueous layer from our previous separation with the full mixture. And what I'm going to do now is acidify my solution. So I'm going to take some 2 molar hydrochloric acid, and I'm going to go ahead and add 4 milliliters. Okay, so let me bring up the test tube so you can see better that we are precipitating our solid. And the reason why this is happening is because we are taking our benzoic acid from its ionic form back to its original carboxylic acid form. Right. Now, my next step will be to add some organic solvent to this. Let me grab my ethyl acetate. Okay, and we will now add 3 milliliters of ethyl acetate to the test tube. Okay, I'm going to go ahead and stopper this and invert to mix the 2 layers. And we're going to gently invert here. Okay, now if you notice, while I'm inverting, my solid is actually dissolving. Benzoic acid is soluble in ethyl acetate, but it is not soluble in water. So if you see, we have a slight little bit of precipitate going on in the lower layer there, but there should be no solids in the upper organic layer. Okay, so I'm going to go ahead and keep inverting to try to get all of our solid to dissolve. I'm going to go ahead and let the 2 layers settle in my test tube rack here. I'm going to use my pipette to remove that lower layer. All right, students, so we're going to remove this lower layer. Now, there is a good amount of lower layer here, so this is going to take a little bit, but we're going to go ahead and remove all of the lower layer. And I have a test tube labeled in yellow here that is going to be for my waste. We won't be tossing it just yet, so bear with me here, folks. Again, always removing the lower layer. And the reason why we do that, folks, is because you're actually able to see your meniscus here. Yes, it would be quite nice to be able to just suction the top layer. However, you're never quite sure whether you've obtained all of it as your meniscus fades. So it is easier to remove the lower layer, ensuring you have removed all of it. Okay, so with the rest of this compound here, which is organic, I'm going to go ahead and pour my liquid into the organic test tube that I have labeled here. Okay, and we will be keeping this organic layer to isolate the benzoic acid. So I'm going to set this to the side. Now, in order to do our second extraction, I'm actually going to take my aqueous and pour it back. Okay, so. Okay, now I will go ahead and add ethyl acetate to my solution one more time. I'm going to stopper my test tube and invert again. I'm going to let my 2 layers settle. And I'm going to use my hand here. Perhaps you can see the meniscus, perhaps not. I don't know how easy it might be to see there. It's visible. Okay, it is visible. Wonderful. Okay, now let me go ahead and remove that lower layer. Now, my second organic layer here, I'm going to go ahead and consolidate them. Okay, we are adding sodium sulfate, so I'm going to go ahead and add just the tip of my scapula here of sodium sulfate to my layer. And this is to go ahead and dry any water molecules that might be part of the organic layer. So I've added about 0.01 of a gram there. And I'm going to pull up the test tube to show you what it looks like. Okay, so you notice we do have some sodium sulfate kind of acting like a little chunk in the ends there. And so we're going to let this dry for a few moments and then filter it into our scintillation bottle. Alrighty, so our next job is to pour our liquid through our filter. And so we're going to use a pipette with a cotton at the end to act as our filter here. And if there's any solids that get suctioned up by my pipette, they will get stopped by the cotton. And we are measuring into a pre-weighed scintillation vial. The mass of the vial will be provided to you in just a moment. Okay, and to ensure that we release any liquid that is stuck to that cotton, I'm going to go ahead and attach my bulb here. And I'm going to just go ahead and squeeze, releasing any liquid that could be attached to our cotton that is acting as the filter. What we will do next is evaporate away our solvent here and remeasure our mass to determine how much benzoic acid we've been able to isolate.